Welcome back, students. In this class we continue Mensuration Chapter 11, Exercise 11.3. Here the first question in this exercise is 11.3. So there are two cuboidal boxes as shown in the figure. Which box requires the lesser amount of the materials to make? So we have to find out of these two boxes are given, A and B, both cuboidal box. So cuboidal box. So here this also same thing. The shape is different, but in the diagrams I have written, the figure I have written is I have written roughly, so you can refer the textbook. So here the solution is both the boxes. Out of these boxes we have to find out which box requires less materials to make. So which box can be made with less materials. So first one, we take the first one. This is the first one. Solution will write. So what are the given data? So L length is given, that is this one is 60 centimeters, and breadth is given 40 centimeters, and again height is given, height is equal to 50 centimeters. So therefore total surface area of the cuboidal is given by the formula is equal to 2 into length into breadth plus breadth into height plus height into length. Therefore substitute the values. This is for the diagram A, or the cuboidal box A. So length is 60 into 40 plus 40 into 50 plus 50 into 60. I have substituted all the datas. Now we have to simplify. 2 into this one is 2400 plus this one is 2000 plus 3000. Multiply these two. 5 6 are 30. That's all. Centimeters square. Now add all this. We'll get 7400 centimeters square is equal to this. Multiply these two. We'll get 14,800 centimeters square. This is for the diagram A. Then for the B, cuboidal box. So we have, what are the data given? Length is given. So this one is length. Length is given as 50 centimeters. Since it is a cuboidal box which is in the square form, so L, B all are same. Length is 50 given, length, breadth and height all are 50. Write down H is equal to 50 centimeters. Now the total surface area we have to calculate. Total surface area. So same formula we have to use, that is 2 into L into B, B into H plus H into L. Therefore 2 into what is length? All are 50. All the data given is 50 into 50, then 50 into 50 plus again 50 into 50. This is centimeters square. So what happens now? Simplify. 2500 plus 2500 plus 2500 centimeters square. Therefore 2 into, add all this, will get 7500 centimeters square. Multiply these two, will get 15 on 200. 2 5s are 10, So 15,000 centimeters square will get. Therefore, finally, the box A. So box A requires, conclusion of the problem is, least amount of materials. So the box A requires the least amount of material. The answer is 14,800, whereas this B is 15,000 centimeters square to make. This is the final statement we have to write. So this is the solution for this first problem, taking the two figures, cuboidal A and cuboidal B. So they had given all the data, that is length, breadth and height. All we substituted the formula using total surface area. Formula given, we substituted the value, we found out, we got 14,800 centimeters square. Whereas in the cuboidal box B, length, breadth, height all are given as 50 centimeters. Then we substituted the formula total surface area. Then we got the answer as 15,000 centimeters square. So final conclusion is, the box A requires the less amount of materials to make. So this is the first problem. We move on to the second one. Second one given is a suitcase with measures of 800 centimeters into 48 centimeters and 24 centimeters is to be covered with a tarpaulin cloth. How many measures of tarpaulin of width 96 centimeters is required to cover 100 suitcase? So here a suitcase is covered, a suitcase of measure, that is 80 into 48 centimeters into 24 centimeters is covered with a tarpaulin. So tarpaulin, so many meters of width 96 is required to cover. So we have to find out how many meters of tarpaulin is required to cover 100 suitcases. So therefore now we will start the solution. First one, total surface area of the suitcase is equal to 2 into, same formula we'll have to use, 2 into length into breadth, breadth into height plus height into length. This is a formula we have to use. We'll substitute the values given. What is the data given for the suitcase? That is, here I'll write length is equal to 8 centimeters, breadth is equal to 48 centimeters and height is equal to 24 centimeters. Now we'll substitute in this formula. So 2 into, that is 80 into 48 plus 48 into 24 plus 24 into 80 centimeters square. So use the same formula as we used in the first question. So this is also a box, therefore box means it is a suitcase. So now we'll simplify this. 2 into 384 plus 1152 plus multiply this, will get this answer centimeters square. Therefore 2 into 6912 centimeters squares. Finally we have the answer as multiply these two, 13824 centimeters square. So what happens, this is for the one suitcase. So we have to write, therefore length of tarpaulin required to cover one suitcase, this one. So next, how many we have to find out? We have to find out for 100 suitcase. Therefore, next step is total surface area of the suitcase divided by width of tarpaulin. So width they have given, so we have to use this formula. So what is the total surface of the area of the suitcase is, we got total surface is 13824 divided by the width is given as 96. Therefore, so here I have written for the second question, I will just cut this because we have to continue this question. So 1382 is the total length of the tarpaulin required to cover one suitcase. So this one divided by the width we have to do. Therefore, after this we get, divide this, we get 114 centimeters. After this, therefore, length of the once again I'll explain. This is the measures of the suitcase given. We substituted in the formula, so we got this one as 13824. Now see, we have to calculate the length of the tarpaulin required to cover one suitcase. This one is this, so don't confused with this one. So this is for this length of the tarpaulin required to cover one suitcase is equal to total surface area of the suitcase divided by the width of the tarpaulin. So this one is, we have to substitute here. Then the 96 is the width of the tarpaulin. Width of tarpaulin is how much? 96 centimeters. So these are the data given. So after this, next step is length of tarpaulin required to cover. Next we have to find out for 100 suitcase required to cover 100 such suitcases. This is also given in the question. So what is the next step? That is 144 centimeters we got for one suitcase. Then we have to multiply it by 100 suitcase. So what is the data we get? Therefore 14400 centimeters is required to cover 100 suitcase. So this is the full detail steps for this problem. So we have to go by step, then we move on to the next question. So we'll see, we can cover the third question here. We'll just see. Next we move on to the fourth problem. So fourth problem given is, third one I'll solve next. So here I have written the question. This is the fifth question I have written. So we'll move on to the fourth one. We'll see, complete the fourth, then we'll fifth, the last I'll solve the third one. So here Ruksa painted the outside of the cabinet measure 1 meter into 2 meter into 1.5 meter. How many surface area did she cover if she painted all except the bottom of the cabinet? So this is a cabinet of measure, see, 1 meter, 2 meter and 1.5. she painted all the parts except the bottom cabinet. So we have to find out how much surface she covered. So for this one, we have to take the solution. I'll start from here since we can cover the third question. So solution, we'll write on the data given. Length is given as 1 meter, breadth is given as 2 meter, this one length, breadth. Then height is given as 1.5 meters. So next, required area. Required area is equal to same formula as we used. Length into breadth, breadth into height plus height into, since we have to minus from this, we have to use one more, that is length into breadth. So since this bottom area should be minused from this total area, so therefore substitute all the values 2 into, that is 1 into 2 plus 2 into 1.5 plus 1.5 into 1 meter square minus again what is the length? Length again is 1 into 2 m square. Therefore multiply all this, 2 into will get, that is 13 m square minus this one is 2 m square, which is equal to 11 m square is the answer. So she covered, Ruxar covered 11 m square of surface area. So this is the solution. So next we move to the third question. Third question, I'll write the question here. Find the side of the cube whose surface area is 600 centimeters square. This is the third one. So the surface area of the square is given. So what is the solution here? First we'll take let the side of the cube be how much? That is a centimeters. The side is not given, therefore we assume the side of the cube is equal to a centimeters. Finally, the total surface area of the cube, we can take, since cube has 6 sides, so 6 is equal to a square. So first what we found out, what they have given in the question, find the side of the cube whose surface area is 600 centimeters square is given. So surface area is given here. So first what we have to find out the side of the cube. Then let the side of the cube be a centimeters. So total surface area of the cube is 6. Cube has 6 sides, so we'll take 6 is equal to a square. Therefore now 6a square is equal to 600. Therefore a square is equal to 600 by 6. So we'll get 100 here. Next, a is equal to root 100 is equal to 10 centimeters. So finally, hence the side of the cube is 10 centimeters. Hence the side of the cube is 10 centimeters is the answer. So this is the solution for the fourth problem. So if you have any doubts, comment me We'll continue the next question in the next class. So in today's class we solved 11.3 chapter 11, 4 problems. If you have any doubts in any problem, comment me, subscribe my channel, share and like all the videos. Thank you.